Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to this masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer system integrators who have crowdsourced a best practices manual to help system integrators scale their businesses. The BP committee released version 6.1 about 2 years ago and is already working on the next version. CSA also offers a certification program and other resources, including professional development, learning from peers, and access to vetted professional service companies, including insurance, legal, and financial, who understand an SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your system integrator programs, understand your customers' pain points, and monitor industry trends and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps system integrators, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations 365 days per year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you are currently a CSIA member, thank you. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's just a great way to get to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. The session is being recorded and you will get a link to the recording in the next day or so. At this time, I'm going to turn it over to today's speakers. Take it away, guys.
Thank you, Lisa. Let me share my screen here, book some slides. There we go. Somebody will let me know if it's not showing. I'm assuming it is. So good morning, everyone. And let me explain who we are, and then we'll get into the content. Really looking forward to the session today. So first with me is Gary Southwell. He's our Chief Executive here at ARIA. As you can see, he's been a cybersecurity veteran in this industry going back all the way into the 90s. And really what we're doing here at ARIA, we're going to talk about today the industry, some background in cybersecurity, and also what we're doing in particular. And of course, I am a sales director here, covering a region in the Eastern United States. Been doing a lot of work in this ecosystem going back about 15 years, and even more if you count some of the other industries. So looking forward to sharing content today. So we thought we'd start with the idea of what are we talking about when we refer to cybersecurity. It could mean a lot of different things, right? So firewalls, network-based threat detection, secure remote access, multi-factor authentication. There's just a bunch of categories that would all be considered cybersecurity. What we're really focusing on today is near the bottom there. It talks about endpoint protection. That is the primary thing that is our expertise. It is really where we're seeing the activity and where we think that you and your customers can get the biggest bang for the buck. So we're really going to focus on protecting operating systems, HMIs, historians, and your critical applications that your customers are using, assuming that you're a system integrator or you're using if you're an end user. So Gary, do you want to jump in and talk a little bit about passive versus active?
Sure. Yeah, thanks, Eric. The industry, especially looking at operational technology, has really focused in the past 15 years with leading with more of a passive defense. And that means that there was obviously some concern about putting active defenses on critical operational devices and critical applications. So the thought was to use something called the Purdue model and build the protections into the network to eliminate the paths in for the bad guys to do bad things in the environment. And that's obviously a necessary uh, set of capabilities you must have. However, a lot of the passive defenses have evolved to microsegmentation and intrusion detection, where they're looking for threats, but they really can't do much to actually stop them once they're in. They're just trying to limit the surface area. And those can get up to be very long projects. We've seen people try to put in microsegmentation, for instance, and take a 3-year project plan to figure out how to deploy that into their larger manufacturing environments. So that's a long time to be without true defenses. The other approach has been more of an active defense role, and you see this in the IT side of the world where people are very accustomed to putting in protections down on every single device. Um, However, this can have its set of limitations, uh, and they have actually caused some issues. If we reflect back to what just happened last July, CrowdStrike and IT level defense was put on numerous critical infrastructure devices across the world. They rely on updates every day to stop the attackers. They're seeing the attacks and then reacting to them and putting blocks down if they can create them quick enough onto the devices on a daily mode. So that's kind of the state of IT, is to react and deploy defenses. Well, they had a bad update. But when you have a bad update into critical devices, what happened next was they basically blue screened all the devices out there, and it led to some serious ramifications where people were down for literally weeks. And you had Delta basically going in and suing CrowdStrike for doing just that. So there's been obviously challenges with active defenses, but if done right, it is going to be an appropriate capability that you have to have within your infrastructure today. There's just too many attacks going on, so you can't just say, no, we'll stick with the Purdue model and try to limit the attackers. We've got to have active defenses. So let's talk about the pros and cons of each a little bit more here. So when I talk about passives over on the right, we're talking about network IDS, IPS, firewall technologies. And these things are definitely needs to have. But unfortunately, like I said, they're typically just trying to limit the attack surface. They're not really finding too many threats. About a decade ago, people said, hey, why don't we just add in signature-based tracking, inside those systems, same way we have over in the IT level to find attacks. That made sense. Unfortunately, ever since something called Stuxnet, which became out with the taking out the Siemens systems in the Iranian enrichment facilities, Stuxnet didn't have a signature that was the same every time it deployed. It changed every time it deployed. We now call that polymorphic malware. And so that kind of blows away the use of signatures, where I can get a hash off a file and say, okay, this is bad, and just use that. It took a while for that type of attack to proliferate, but now it's become really the majority of the malware ransomware today you have out there is polymorphic. So you have a limited amount of protections you're now getting in passives, even with signatures. So puts the pressure back to come back with something that's more active. So the active defenses today, you'll see things like AV, and then something called next gen AV is leading the way. And they're using, they'll still use signatures, but more and more they're using what we call looking for indicators of compromise. That means they're on devices, and if an attack happens, they've actually been watching and seen the pattern of the attack and figure out that pattern and say, okay, we know this is bad. We can identify this attack. They do that activity up in their cloud, and then they send down updates to the devices. And I just mentioned that that's what CrowdStrike does. The problem is you're always chasing the attacks, and now with AI, the attacks are evolving very quickly. So if you're always 2 weeks behind the latest attacks and coming down with ability get widespread protections across all the devices, that becomes a real challenge to keep up. The other problem is that there's that assumption, kind of like Delta had, and they regretted it, was that, hey, I am opening up my critical devices for all my production operations to the cloud. It's going to have continuous internet access. I've now opened up a path, through my passive protections, and I'm going to rely on a vendor out there to make sure that they provide me properly tested and adequately protect me with their solutions. And of course, it just took one bad update. It wasn't intentional by CrowdStrike, but it took out their whole installed base. And it actually required people to actually go around into the devices manually, set them up in safe mode, pull back the update, put the appropriate update, repair the OS, or put the appropriate update on. Those types of steps were involved. So even CrowdStrike now comes back, if they're going to be putting critical infrastructure, and say, don't do continuous updates from us. Test them in a lab somewhere or on non-critical typical workers' laptops and desktops first, and then roll them out into your critical devices. But meanwhile, you've taken that a couple of weeks of bad attackers, and if they've been getting into your critical devices, you just removed the whole advantage that CrowdStrike and others were creating. So these are the challenges you're going to have, with those types of defenses. And being reactive, meaning that you can't keep up, you're always going to be behind. And there's lots of today's, like I said, malware and ransomware, which is polymorphic. It's changing all the time. That's a problem. And the other problem is they can only put so many IOCs or signatures in a given device before it starts to suck up massive amounts of memory CPU power to actually go through and scroll through all those database in which would they have. So they're only keeping about 50,000 of these things active any moment in time. So they're moving them in and out. Creates a complicated system. So there's a real challenge there. What we think this means is that the industry is now ready for what we call a fourth generation of active defense, something that would actually come in and stop any form of polymorphic malware or virus, but it also should start to take out these more sophisticated nation state attacks as well. And they're very, very dynamic, using different techniques all the time. So we've got to figure out a way to actually go and stop them as well.
I think that's perfect background, and that's a perfect segue. So, really what you're talking about, these are issues that are appropriate from the enterprise IT world, but they're particularly challenging in the OT world, which I think is why we'll talk a little bit now about kind of the nuances of that spread. One of the real challenges that we see on the back end with our partners, as you know, Gary, is that the enterprise IT folks need to sort of take into account the nuances of the OT and industrial controls networks. They have different requirements, and that's true in general, and it's particularly true in regards to cybersecurity. So there's a well-known triad, of CIA in terms of confidentiality, integrity, and availability as the focus on the enterprise IT side. But when we're talking about physical systems that are running, you're talking about safety, harm to the environment, and still availability, of course. Patching, again, in the IT world, you're used to patching constantly every week. It's known as Patch Tuesday for a reason. Versus as the integrators in the audience know, from the OT side of the house, it's once a month, year, sometimes never. And then again, what we see, we always see when we work in walkthrough facilities and we talk with folks, we've got old operating systems running, Windows XP and Windows 7 workstations, and again, that's not something that an enterprise IT is going to have to deal with. You mentioned connectivity to the cloud, which there was a big push over the years to merge the digital transformation and Industry 4.0 and merge both networks. But now we're seeing going the other way, and folks are now implementing air gaps, or so we kind of use the term semi-air gap and imagined air gaps, and we can talk about why we use statements like that. And then again, from a management perspective, again, there's a lot of dedicated resources on the IT side of the house. Versus the OT side, there's some folks that, quite frankly, don't have any tools in place, or they're very nascent in their approach. So I don't know, Gary, did you want to speak to any of these issues as we move forward?
Yeah, I think you hit them, but it's key. What the challenge really here is that we've got to come up with a very simple way to protect these critical OT applications.
Yep, I think that's it. And we made mention of the Purdue model. I think probably everybody in this audience is very familiar with it. But this really isn't a security framework. This is just a segmentation framework. And again, different issues when you deal with each different level of that Purdue model. And again, we've talked with some of these things, but these are, again, for our audience, this is what your customers are facing in terms of cybersecurity, right? There's some of that convergence of IT and OT, or a little bit of movement back the other way. Legacy equipment, a lot of the supply chain risks, as Gary articulated here a little bit in regards to CrowdStrike, and we'll talk about that here shortly. And again, you're trying to do it very simply without a constant management and administration burden. Is that fair to summarize, Gary, or anything else you wanted to add?
Yeah, I will say with the OT, we've seen a sudden need to have IT, OT work together here. So we were seeing that convergence. But even the IT guys are realizing the OT environment is not the same as the IT environment. So they're trying to figure out how do we protect it without breaking it. If you've had the Purdue model in place, it was in for good reason, and you don't want to do a lot of continuous patching and updates, as Eric said, because that costs money. That you're trading security for uptime. With continuous patching, for example. So the OT guys are saying, I want to patch once a year if I can during normal maintenance windows anyway. I don't want to have, monthly, patch Tuesdays or whatever built into my schedules, because that means I'm down for maybe 8 hours in a plant. And if I'm running it 24/7, that's time out where I'm not producing revenue and the bottom line. So there's that real pressure. But the other side of it is these entities now have things like cyber insurance, and the cyber insurers are saying, if you don't have adequate visibility that you have protection on every single asset in your environment, you're not getting your policy renewed, or we'll find you in violation of your policy if you do get attacked and we didn't know about those devices, and we're not going to pay. So, they have like, we've got to solve this problem. We've got to have a way to protect those endpoints very simply that doesn't open them up to additional risk, doesn't force continuous updates, does not make us do patching all the time, but gives the IT, the guys, the way to say, I can have visibility, see what's going on there, make sure everything's protected, and make sure then we're dealing with compliance issues if those are an issue, or just getting my cyber insurance done. So these are all the industry issues that are being grappled with. So I think we'll talk to you in a few minutes on how we can help you guys solve those problems.
Yep.
Yeah, so there's lots and lots of different frameworks out there. We, as well as Rockwell, have kind of gravitated to the NIST cybersecurity framework, if you're going to gravitate to one, because it kind of puts the whole set of challenges on one slide. There's nothing. The genius is boiling everything down to one slide and then come up with some form of action which you can take, which is a real problem with a lot of these cybersecurity frameworks. A lot of it's just the compliance for the sake of compliance, doesn't protect you at all. But this one does. So the framework has got like these 6 silos inside them. And they start off with just saying, hey, without going into each detail, the left-hand side is all about planning and protecting. Okay, I've got to have the right strategy, the right plans in place, the right people, all of that have got to be in place. I've got to make sure I can actually identify what I'm protecting, and then I've got to protect it. And if I do that really, really well, hopefully I'm not going into the right-hand side of this framework too often, right? Because that means I'm stopping a lot of the problems before they become problems, or if they become problems, I take them out quickly before they spread and do any harm. Now, if I go to the other side, that's where I'm like, okay, I've got problems. Now I've got to sort through them and come back and see if have I solved the problem? Is it still lingering? What kind of cleanup do I have to do? Or, geez, the attackers are in here and I don't even know how far they've progressed. So I've got to do a real investigative response set of activities. You're often bringing in third parties in. I have to have them on retainer. That gets really costly. You can get into the millions of dollars, as we've seen. And then I got to spend time recovering. All right, so these are all the things you have to have for in your plan. So I better have somebody in IR and retainer, but I sure as hope I never have to actually go and use them is what I'm trying to get to. So if you do a good job on the left-hand side of the framework, you don't spend a lot of money on the right-hand side. So that's what we're trying to go off and do here is give people a way to, and you guys are system integrators, you know, you're gonna have a critical role here, is a way to help people set themselves up for success so they don't have to pay for it, you know, with really expensive people on retainer all the time.
Yeah, yeah. This is a good framework, and we've called out here the place where we played with the little green box there, a little preview of what you're going to talk about here in a bit. You know, so NIST is one of the common ones, but we just wanted to introduce several others because there's all sorts of framework standards, directives, regulations that are relevant to industrial controls in certain industries and vertical markets as well. But the important point, and you already mentioned this, Gary, is compliance does not equate to protection. And that's what we're really talking about. These frameworks are great guides. And obviously you need to follow regulations, of course. But again, even that doesn't mean that you have protected your environment. So that's really what we're hoping to talk about throughout the rest of this. I think the next section we did want to talk about though was just a little bit more background because you know sometimes we're still it's incredible to me, Gary, but we still hear folks say nobody's going after OT networks. That's an IT problem. You want to talk about how false of a premise that is?
Yeah, I want to say really over the last just about 2021, that really has flipped. You could see it with the Colonial Pipeline onward, you know, people really started to wake up and said, oh my gosh, you know, I thought the passive protection we had in place could stop these attackers. And yet they were getting around those passive approaches. And we'll talk a little bit about that in a minute here. So the real challenge I think people didn't realize as well is that the average cost of the OT cyber attacks is almost double that of an IT attack because what you're usually doing is you're taking out critical infrastructure, which is impacting revenue or impacting, you know, critical services. So they become very, very expensive and then difficult to deal with because often if you get into manufacturing, for example, you know, the whole thing is I've got to keep everything running and running at the lowest dollar per overhead unit that I'm pumping out. So I don't have a lot of IT staff on hand or people in the factories to deal with issues. So when they do crop up, they become a major catastrophe because now I'm also trying to pull people in and get outside support from vendors in and have lengthened the time to actually, you know, figure out what's going on and actually stop the attack. So it probably means I've gone into full production, you know, stop and uh, till I figure out how bad things are. And we've seen that, you know, people be frozen for like 2 weeks in some of these attacks. You know, Clorox, for instance, I just recall that one more recently. You know, they had an impact that took them over a quarter to sort out and make sure they were actually had figured out that the attackers were out of there and over. So it actually stretched into 6 months of massive revenue impact, and of course hit their bottom line. But there's others out there. You know, WestRock was famous because they got hit by a malware ransomware attack, $200 million of actual production loss. We've heard things like the utilities being attacked. Ukrainians have been attacked with something called sandworm from the Russians. We'll talk about that in a couple minutes here. We'll go through that actual attack. But there's things like Volt Typhoon, and I'll let Eric talk a little bit more about that, but that's the Chinese are coming in and they're just trying to seed in and have a footprint in here so they can really wreak havoc if they want within all forms of critical infrastructure. And then there's the more mundane. It's if I look at most of the attacks out there, they are still, you know, for the vast majority or 70% are malware ransomware. All right. And you know, it's this uh, ability to have these polymorphic malware viruses coming into your environment and then spreading quickly. And these things have done real damage. You know, Merck had to sue their insurers to get paid, and it was a $1.4 billion. That was the damage in which happened there inside their environment. Obviously, pharmaceuticals are a real challenge. We're deployed in one of the world's largest ones. We'll have a case study on that. And it's not just you know, the viruses and the attacks, because if you've got to get the FDA involved to recertify your line as safe, that can take months. So that can be a real problem for some of these manufacturers.
Yeah. So if the message to the system integrator community is, if you need help explaining the challenges that the real threat that your customers are under, we can help. We've got some data to bring. Um, and as we, as Gary has talked about several times, we're really at a critical point. A lot of this is driven by AI and other technology advances. And some of it is just kind of we're still in the 1.0 version of that concept of signatures and indicators of compromise, Gary, and we're really seeing a different type of attack today than what we did previously, right?
Yeah, that's right. I don't think we can rely on reactive approaches anymore. We're going to have to be something that's more proactive that can block these, bad actors with the actual techniques they use right from the get-go, and not have to rely on these updates, which have proven to be a problem if you've got to rely on continuous updates.
Yep, yep. So you mentioned we mentioned supply chain attacks as kind of a new vector that we're seeing more and more and more, and this was one that we all looked at. But do you want to talk through this slide, and then we'll show this again with a little update later, Gary?
Yeah. Just in general, supply chain, and these are your vendors that you rely on, everything from your DCS vendors to your application vendors. They're coming in here, and it can be the integrators themselves, coming in and providing services. But they're coming in and they're basically walking around the actual passive approaches you have, literally walking around many times there with USB sticks doing updates or providing their updates in a lot of these environments. So, not everyone has got sophisticated labs set up where everything is thoroughly checked, and you make sure stuff is sorted through when you get into these customers. Um, and then there's other types of supply chain attacks that come in very insidiously that are really hard to detect. So we just picked the one that's famous here to show you, what can really go wrong, where all the protections you might have are not going to work. This was the SolarWinds attack made famous back in 2021 for several reasons. But what had happened is SolarWinds, their Orion software, was used heavily in a lot of environments, some manufacturers, but mostly like government and other services industry used it heavily. And what happened is the attackers actually got into the SolarWinds environment and got a shim inside the Orion update pipeline. So when Orion sent their updates out to their customers, continuous updates, as I talked about before, but this is from an application level, suddenly when they went to deploy those, everything started to deploy, but all of a sudden this little shim was also deployed. The shim was actually a little bit of code we call shell code that was there. And what it basically, all its function was to do was to quietly open up a back door outside the environment so they could pull in additional code, and that would be malware, and then allow the attackers to come in and then take control. So you can kind of see there's a whole bunch of steps here when things would happen. But when someone looked at the update of the Orion code, they'd say, has it got a valid cert? It does. Good, let it run. Pretty much everyone's going to do the same thing, whitelisted or not. You're going to say, good, let it run, off it goes. And then you don't keep checking. So you need something that's going to continuously check these applications to see what happens next, so that you can actually pick up these bad guys when they're starting to do these strange techniques, like run a little bit of shell code and look for a backdoor. All right. So there was many steps to these nation state backed attacks, and this was nation state backed, in which they're going in and they're beginning to come in, sort through things, and then decide what they're going to steal and take control of and do harm with.
Yeah, it's no amount of firewall is going to catch an update from a trusted vendor, right?
Right. Yep.
So, you alluded to this, and this is one that's really become more and more ominous, in my opinion, just as a citizen of the country. And just for those that have not heard of this, you mentioned Vault Typhoon is a Chinese group. And a few years ago, we've known for a few years now, the FBI and CISA have known that they have infiltrated critical infrastructure all across our country in terms of small and large water and wastewater, as well as energy distribution and generation. And so this was just from, I guess, just a few weeks ago, where another firm, Dragos, they basically described in depth what was going on in a Massachusetts electric, light, and water. And again, the message here, folks, again, for you folks that are selling into the water, wastewater segments, the power generation, and the other critical infrastructure industries, Vault Typhoon is there right now. And what they're doing is waiting to launch at some point in the future when they decide that it's at their political advantage. This is not in dispute. They are, and just because you're a small utility doesn't mean you're immune to this. So this is really imperative that we spread the word and help these entities to be prepared for this, because they're already in their network. I don't know, Gary, did you want to add anything, or is that pretty?
No, I think that covers it.
Yeah. Okay. Well, so we've set the stage, and we're just about halfway through time-wise. So, hey, let's talk about what we've got here, Gary, and I'll man the slide and let you talk through it.
Sure. So just to lead into this, I mentioned before earlier that you know, active defenses are going to be the way we're going to have as a tool in the tool belt to solve this problem. It's not the only tool, but I believe it's one of the critical tools out there if done right. It can give you a quick way to get into your customers' environments and help them provide meaningful protection from today's polymorphic malware ransomware to also thwarting a lot of these nation state attacks as they come in and try to do what I would call a code level attack. We'll talk about that here in a second. So this is our product, ARIA AZT Protect. It's a next generation, we'll call it a fourth generation endpoint protection product. Fourth generation means it's got a different approach than what we've seen. First few generations were more signature, whitelisting, and then people came in with the let's find the indicators of compromise. And whitelisting just was like, hey, we know which application is supposed to run. We check the certs and they're there, good. We allow them to run, that type of thing. But lots of complications with those products, made famous by Carbon Black and others, to make them actually work and keep them up and operational without massive false positives. So people kind of got away from those as a second generation approach, and then went heavily to the third generation, which was depending on the indicators of compromise. And we just talked about the challenges with that solution. So in this approach, we're going to come in and say, what we want to do is build protection in that doesn't need updates. So that's like, whoa, mind blower, doesn't need updates to the latest and greatest attack. Yep, there's this new attack, and now I've got to figure out a way to stop it. We're trying to build that without that. So we've built a solution that's got about 6 patents already implemented and about 3 others that are in process to do just this. So how we do this is we're building what we call a kernel level driver. And this makes us go right in at ring 0 of the kernel with our protection. Okay, now a lot of people have tried this and got away from it. If you do this wrong, you can blue screen devices. Sounds a little familiar, because a really good solution out there, CrowdStrike, I don't want to cast stones on it. They did a really good job. They built a kernel level driver so they could actually see what was going to happen and have that visibility to understand these indicators of compromise right down at the kernel level so that they come up with an adequate way to respond. Problem is, if you don't do this right, you will blue screen the kernel, which means you blue screen the device. All right. So, but it is the appropriate place to have this right level so that we can stop these techniques as they appear before they execute. If you stop them before they execute, you stop them before they do harm. So let's run through this. There's a little animation here to literally show you what I'm doing. So when we deploy our agent, it actually deploys. You can deploy it on a running system. You don't need to actually reboot it. When you deploy it, it'll just come up and work. And it's going to go down at the kernel level. What this means is, if you're into geek speak, we're coming in at ring 0 at the kernel. What's the advantage here is, as we sit there and we are watching everything trying to execute. So every instruction coming down, every bit of code trying to execute, we can see it's loading into memory and then trying to make its way through to execution. So it's giving us that level of visibility. So we keep going. What will happen is what we can do is, and we've got a series of what we call countermeasures. Those were brought up in this slide. The first countermeasure is there to just look and make sure that nothing we don't want to run will run, right? So it's a good way to make sure things like malware, ransomware that are usually executables just appearing are going to be blocked, but also can allow you to lock down your infrastructure. That sounds a lot like whitelisting, but we went one step beyond that because we're going to continuously watch the applications as they run, because often the bad guys are going to have other techniques to come in there and like, I'm going to do an intrusion into that application, and I'm going to put in some form of uh, program that will allow it to run. Can you step back one, Eric?
Stay back.
Yeah. So I'm going to allow it to run. So like an injection, which we show here over on the right-hand side. I'll inject code into that program, or I'll run something, I've mentioned this earlier, like shell code that just suddenly appears in memory, and that's going to run. So all these things are code level techniques that are used by these hackers to come in, often by the nation state hackers or any other form of intruders. Why? Because these tasks are automated. They want to do as much automated before they actually go in and get maybe humans involved, pulled in to come in and take control. If we can stop that from happening, we basically stop the attacks. Okay, so we need a way to block all these various malicious, what I'll call fundamental tools or techniques that are used, besides just making sure that no malware or ransomware can execute. So that comes to what we then have to do is have a series of countermeasures, if you want to show that, Eric, in which we show just a snapshot inside our user interface. There's a bunch of countermeasures we have that are built to take out these malicious techniques. And it's where we sit at that ring zero in the kernel that allows us to apply and catch these techniques as they're happening with these types of tools. Okay, so what's interesting about what we do though is, since we have about 15 of these things, what stops what when, and how does this all work, and can we make it fully automatic and so nobody's involved? So there is a form of AI that runs inside our tool that makes sure the right type of countermeasure triggers, and we take the appropriate action to block that attack before it progresses so that we can stop it in its pre-execution phase so that no harm will actually take place. So you can kind of think of it as, our CTO invented this technologies. We're going to make these attackers and their attacks basically inert inside the environment. They'll be there, and we're going to warn you about them, but they're not doing any harm. Keep going there.
Well, you mentioned the issues with running at the kernel level, and I know the first thing we get in the field when folks talk about that is, my gosh, how is it that you're not interfering with the operating systems and the applications? And that has to do with the tiny footprint and the AI engine on the back end, right, Gary?
That's right. Yeah, that's glad you brought that up, because some of the challenges we faced going into OT is that, hey, I'm running on machines, I'm sweating the assets. Some of these machines are 5 years old. Some of these machines are 10 years old. Some of these machines are running applications that are now no longer in support, on OSs that aren't in support. And you want to make sure not only you're protecting the latest and greatest, but also those devices as well, because they're not even going to get patches. But we went to one large manufacturer and they were like, it's going to cost us millions of dollars to just remove these 200 machines running on XP and create a whole new stack. So we're trying to sweat that as long as possible, because that's a 2-year plan. Help us for that 2-year period. So that, in fact, as Eric said, but you go into those devices, you're like, I better use only one thread, and I better have a minimal footprint there so that I don't impact the way those things run.
Yeah, I always stress we measure our footprint in megabytes, not gigabytes, and
Yep.
that's something everybody needs to understand. And I guess so. We talked about the agent, which is really doing all the protection work, Gary. But the overall architecture is very flexible. But this is kind of the full Monty, if you will. You want to speak to sort of what we're looking at here?
Yeah, as Eric said, we talked a lot about what's over here on the left-hand side, and that's what we call it, our trust agent. So that can be pushed out and deployed automatically with any distribution tool that you or your customers use in these environments, and it will actually come in and with the Windows version integrate itself automatically and just come up and run. So it's fully automated in that level. So what it's doing is coming in, installing itself, and then it's got a set of policies and other things that are just built into the base level system. And it can be set to protect right out of the gate if you so desire. But most of these devices are going to come back up from factory defaults to just be what we call in detect mode, saying I'm going to come in here, profile all the applications that are running on the device, look at them, create an immutable ID for them that's built off the binary and the memory sockets in which they use. That's part of one of our patents, so they can't be spoofed. And we always know which application is, and if something should change with that application, if it's been adulterated in some form, we're going to know it and stop it from actually executing that version of an update, or that version of that application that suddenly appeared is going to be stopped from running. And those are the basic concepts. And then we have these other countermeasures which can also be set, and they're usually often in detect mode. Now, that's not preventing a lot of attacks. That's just, getting you on there and running. So the device to the right is what we call our trust center. So it's not active in doing anything other than setting the policies down on those endpoints, and the endpoints do all the work, and then monitoring, what's happening in your environment. So most of our customers today, they have at least those two pieces of the solution in place, where they have a trust center, and it's often, if you look at the Purdue model we had there earlier, it's usually within the factory DMZ. So it's usually running there at that level for most of our customers. Some that have more sophisticated environments will put the trust center higher, and we've got some that are putting the trust center up in AWS. Again, the only communication that's going back is through port 443 and 7443 when we communicate back and forth. So we can leave that very, very closed down, and only the device on the left can ever initiate communication. So it's meant to follow all the best practices so that we can keep your passives and your measures in place without violating any of that, and add us into those environments very, very simply. Now, the Trust Center is there to, like I said, set policies. So that's where you go in, and after the agents have been deployed, they will come back. Now I can actually go in and say, okay, I looked at everything, I've accepted everything here, looks good, and now I'm going to turn everything on. Now, there might be a chance that maybe you accepted something that already had some ransomware malware in there, that's not doing anything at this time. But if it does go active, the other countermeasures are going to pick up those activities and then isolate it so that it can't progress. So that's what the other countermeasures are there for, even though you're saying it passed through that one countermeasure where it was looking for was it allowed to execute or not. The rest of them kick in. Okay, so that's there. That's cool. And then you've got people saying, well, I've got an integrated IT architecture here. These are larger, the IT guys want to come in. I've got 16 plants, and that's great. We got trust centers in each plant, but the IT guys need to have visibility. You said you can connect to a SIM. We don't have a SIM. We're like, no worries. Here's this trust point. It's going to show you everything that's happening down at each of the trust centers and give you that one screen visibility view. And so now you have got complete visibility, what's protected, what's happening, what's for compliance. But it's also a point where you could say, hey, the ARIA guys do have an update, and I do want to push it down once a year or whatever, because it's got new features in it. And I'm going to use that as my point to distribute that further down to the plants, and then the plants can deploy those things when they hit their maintenance windows. So it's a way for us to provide you everything you need for managing our applications, and we're not making any assumptions that you've got all these other tools. If you got SIMs, you got everything else in place. You don't need the trust point. Again, take what you need, but we're trying to also give you system integrators a view that these are things that we have that you can then build into your project plans as to how to effectively go and deploy small operations to very, very large operations. In fact, we've got people that we have a new capability that's just coming out of our latest release, which allows us to just deploy trust agents with a local console, and there's no trust center actively involved in monitoring and managing. We just have a trust center there to do the licensing, and then you can distribute these agents out on USB sticks, and there's never a need for them to connect to a trust center. We've had that come up out of a utility who wants to protect like nuclear control panels and the like, and they never want those connected to anything. So that's where that came from.
Yeah, so I think the message here is it is a very flexible architecture, and from a system integrator community perspective, you can build some obviously deployment services and management services as well. And what we're finding as we really just have gone to market here, focused on industrial controls, is that a lot of our partners are finding the sales process a little easier with our solution, and the implementation process to get something in place. And then you can bring in the back end multi-month, multi-year engagements like Gary was describing earlier, where network segmentation and those much more complicated deployment type solutions. But you can use ARIA as a way to, number one, get some protection quickly, and sort of establish a cybersecurity presence at the OT level within this customer base. So we've got, I guess I'm just checking my watch here. So we've got about 15 minutes. This is sort of the summary slide, really to tell them what we told them. And I don't know if we explicitly mentioned this. So some of the things I do want to highlight here is our solution we talked about legacy operating systems, and we can go back all the way to Windows XP, SP2, also various Linux variants as well, and even some neat stuff with Android as well. We can be turned on pretty quickly and installed very quickly, again, compared with some of these other more cumbersome solutions. We can work fully air gap. Gary just described that in terms of even a laptop without the management connectivity. But this is kind of the summary slide. And Gary, before we get to case studies, do you want to reinforce anything on this slide or anything that's not on this slide?
Yeah, just make sure we cover it. We talk a lot about Windows because we find that heavily in manufacturing, but we support Windows and Linux systems of all kinds. And like Eric said, we got some work we've done with Android and ARM cores as well. So we're getting into a lot of these next generation Factory 4.0 application solutions as well.
Excellent. Well, I think this is the meat of the thing. For me, when I was coming on board here, this was the most educational for me. Gary was really understanding how these things work, and how the malicious attacks work, and then how our solution mitigates. So this is a slide we saw a little bit earlier, but we've added a few features to it. So do you want to speak to this slide again?
Yeah, so I talked about the what we call here the kill chain of the sunburst attack there on SolarWinds. And I mentioned all the steps here. There's 14 steps shown here. So if we were involved in this, if we sat there, you would have seen in this case 7 places where our countermeasures would have kicked in, starting right at step 2. Sure, it had an update that had a valid cert. That was fine. But what happened next is instructive. Shellcode started to appear. We would have just stopped it right there. After that, it was trying to download some additional executables. Those would try to run. Our no trust would say, no, that's not going to run. If you allow that progress, then they were trying to inject themselves into other running applications so they could better take control. There was privilege escalations. So they were trying to go from user level to system level to take full control. Malicious scripts are running. Stuff was appearing in buffers to allow them to spread the attack. All these techniques we would have stopped from executing. What is also instructive is this was if you'll recall, January, February 2021, when this all came out. There were a lot other big vendors were there in these environments, because this hit like over 90 identified locations. Some of them are actual government agencies, others were manufacturers, others were critical infrastructure, but mostly were services companies. So Palo Alto, CrowdStrike, Microsoft, as well as SolarWinds got pulled in front of Senate hearings, and Mark Rubio asked in the late February timeframe. So we understand that all of you were present in some of these places that got attacked, and then each one of you got bypassed. Is that correct? And they all answered yes. So bypass means that the attackers came through, and not only did they not detect them, the attackers actually took out by turning off their solutions. Okay, so this was very telling because this was a very sophisticated level attack attributed to the Russians. But if you can actually turn off your active protections, you're in real trouble. So this is what actually stimulated me to actually come back in and say we need to have this type of solution that not only can do these levels of detections, but can never be turned off by attacker once it gets in there. So that really was our base case. We had to solve this problem, and that's what led to our initial product set of features.
Neat. Very instructive. We've got one more here that is similarly a different type of attack though, right? This would not be considered supply chain, I don't believe, correct?
Yeah. So this is very similar. This is the sandworm attack. Those are Russians that were targeting Ukrainians. And I can also lay over to the Volt Typhoon attack here as well, using similar techniques. Now, they may be coming in and utilizing credentials and other things to get a foothold that we won't see with this approach. But it's usually what happens next is where we see it. Because in this case, the attackers are trying to use some form of binary to launch in to establish control. Other cases, they're coming in, they're trying to go from user level to system level and privilege escalate. We're going to stop that. We can also see lateral movement and we can block that. So all these types of techniques that they use to actually go and spread and get to the devices where they really want to do the most harm, we can block them, again, with our countermeasures. Again, all these things are built into the product. We didn't have to do updates or anything. They just work automatically.
Yeah, we didn't need to hear the word sandworm. It was running and protecting just
All Typhoon, we didn't care. Just like,
all
yep.
that. So here's another one, and I know we do want to get to questions, so we'll probably try and keep it brief. But this was an interesting one that is brand new and actually also speaks to the unique way that we go about things, right, Gary?
Yeah, this one was shown at Black Hat in December of 23, and the attackers there came in. They're safe breach. They're actually a red team that comes in and says, hey, there's these new level types of attacks. What they identified with, to make it simple, was what we call a living off the land type of attack that was actually going in and attacking at the right at the kernel level and taking advantage of what they call thread pools, which are the way you actually utilize the different threads of the CPU of the equipment. And they have access to all kinds of code out there. So they said, hey, we tested against everybody in the Gartner Magic Quadrant, the leaders, and none of them even picked this thing up. And it took many of these, vendors months to come back with a way to actually stop this level attack. We got a hold of the attack after they showed it and ran it against the initial code we had been out in production at that point in deployment for 6 months. We hadn't done any updates to it. So let's see what it does. We picked up every one of the 8 attacks automatically right out of the box. So again, it's just a testimony that it's a different form of going in and stopping these attacks. We're looking at the techniques in which they go off and execute. So we can pick off a lot of these living off the land techniques, with our countermeasures and, block them.
Excellent. And then we've got this one case study. I don't know how detailed you want to go into this, but again, just why we were chosen, and then we'll move on to get some Q&A here going.
Yeah. So this was a very large manufacturer. This is in pharmaceutical, probably one of the largest at the time out there. Again, we're going back about 3 years at this point. You can imagine, think about it. If you're in the middle of COVID and you've got COVID level products, you've got to have protections, and you cannot afford to have those lines go down because those could be $1 million an hour lines. So you have to have those types of things protected. So that's the type of environment we're going in. And oh, by the way, is we as a security provider, you can go on those equipment, but whatever you do not do anything to blue screen this equipment, because if you blue screen, we're probably down for weeks because the FDA is going to come in and do an investigation. So we're in deep trouble. So we were in the crucible to actually show that our product could work and work under these types of extreme duress conditions. So we had to get it right. So in this customer, we proved our worth, and we showed that, we can actually build a kernel level driver that didn't blue screen on you and cause these issues. No one even cared at that until CrowdStrike had made it famous last July as to what they were doing. And we were like, this is perfect, because we did all the work for years, working with this large customer. They put us into over about 40 sites worldwide. Very, very happy, with us and our performance. But the advantages were just there, right? It just was easy to deploy. As Eric said, they could just deploy this quickly, have a whole factory up and protected, within about 4 hours. Could work on whatever they had. They had a lot of XP to the latest stuff. It just worked. So they loved it that way, and just stopped the attacks, and they weren't having any issues with false positives. Versus what they were using on the IT side. They had like CrowdStrike there for the IT side, which they were very happy with. And they looked at other approaches like Carbon Black's whitelisting product, but they were like, this is really difficult to make work. And you guys continuously protect, where they just look when it boots up and make sure the cert's right, and then if it doesn't reboot, they don't do any further checks. So we're like, yep, nope, we're continuously checking. So this was the proof point for us, and this is up on our website if you want to come and take a deeper look.
Awesome. Thank you, Gary. And we I think are pretty close to the time limit here. So if we can get access to a question or two, we can try and do that. But we will follow up if there are. I can't see the chat or the Q&A. If there's anything sitting there that Lisa that we should deal with, can you help me on with that?
Sure. I do have a couple questions here. It says, and forgive me, I'm not a technical person, so I'm just going to read it and hope you understand it. What is the difference between this and application whitelisting?
Yeah, I tried to describe that a little bit. I'll take that. So application whitelisting is basically a technique where you um, uh, learn on the applications, usually identify them by their cert, and you say only these applications will run on a system. So as I was indicating earlier in the presentation, that's a way to keep things you don't want running on a system from running. So it could stop, malware and ransomware. The problem is it doesn't do anything once the applications are there and running to dynamically continuously check them to make sure they still are the applications as they said they were, and they didn't get what we call adulterated, meaning like an injection or some other type of attack is taking advantage of them. So that's how we differ from those. And they only do one of our countermeasures that you'll see, and where we think we need about 15 of them to take out all forms of attacks.
All right, next one is, how does the automation work?
So the automation is based on what we call reactive AI. If you think about, I don't have much time. We know about generative AI, and it's really, really CPU intensive and difficult. Reactive AI is boiled down AI, which makes quick decisions on limited amounts of data, so that we can apply the appropriate countermeasure and stop the attack as quickly as possible, with burning the fewest CPU and memory, lots of memory as possible.
You said this works air-gapped. Can this support devices that aren't even networked?
Oh yeah, that's a good one. Right. So we've had oil companies, I'm just thinking of all the customers, power plant companies, others that saying, hey, I've got some of these devices out here which aren't even network connected. They're kind of like little islands. And I mentioned the nuclear consoles is one of those examples. So they never want those connected to a network. But I want to have your protection on those, because they do take updates, because people will jam USBs in there and we will update them. So I want to have protection there. So we built it so that, yep, you can do it that way. You can load us via USB there, and it'll just run locally, and you'll have a little local console in which you can control it.
This is a personal note. It really stresses me out when you talk about cybersecurity and nuclear plants, just as an aside.
Sorry.
I'm
Got to
glad you
protect them
guys are
though.
thinking about it. Could this be used in conjunction with other endpoint protection?
Yes, so we go into a lot of situations. They'll have some more of the what called the legacy signature-based programs. You'll see it from like McAfee, Trellix, Symantec, you name it, they'll be there. And we can go in right alongside, or Active Directory from Microsoft. We'll go right in alongside and basically, supplement all the things that they don't do.
All right, I have one more question. Well, first of all, I want to address the audience. Yes, this is being recorded, and you will get a link to the recording. It will also be on our website, controlsys.org, as well as on YouTube. Final question before we close it out. Seeing what happened with CrowdStrike taking out all its customers last July with a bad update. Does Microsoft verify your code releases?
Interesting. Yeah. So when we do code updates, we do run them through the Microsoft process. So Microsoft will actually give you a valid cert and that it's signed code. But what they also do is they actually run it against their in support operating systems to make sure you don't blue screen. So that every time we do an update through Microsoft, we make sure it goes through that process. And Microsoft didn't really appreciate it when they were getting blamed, what happened last July. And they basically went back and said, yeah, CrowdStrike was violating our process by doing updates without running them back through us. So Microsoft really didn't appreciate that tarring, but they do a good job with that. So, but it takes up to 8 days to get an update back from them. So I totally understand why CrowdStrike can't do it because they can't always be a couple weeks behind, the attackers.
Yeah, understood. All right, so we're going to wrap it up. My colleague is going to put some slides up for me, Eric, or Gary, if you want to pop your contact information in the chat for anybody who needs it. I'll give you something to do while I'm doing this. Okay, so if you, that's my old script. On behalf of CSA, I would like to thank our speakers, Eric and Gary, for this informative discussion. I would also like to thank ARIA Cybersecurity for sponsoring this event, and of course, thank you for attending. And that's a wrap. Once again, thanks for joining us and have a great day.
Thank you.